Ever looked at an igloo and thought, how could a house made of snow possibly keep you warm? It sounds like a total paradox, right? But the traditional snow house, a masterpiece of Inuit engineering, is a brilliant example of using nature's own materials to create a surprisingly cozy shelter. It's not magic, it's pure, ingenious science. Today, we're going to dive into the thermodynamics and clever design that make an igloo one of the most effective survival structures ever conceived. Forget what you think you know about ice and snow, because this is going to blow your mind. So, what's the secret? It all starts with the building material itself. An igloo isn't made from solid ice. If it were, it would be a terrible insulator. Instead, it's built from blocks of hard, compressed snow. The key difference is what's inside the snow. Countless tiny pockets of trapped air. Air is a fantastic insulator. It doesn't transfer heat very well. Think of it like a down jacket or a thermos. The millions of air bubbles trapped within the snow walls create a barrier that dramatically slows down the escape of heat from inside the igloo to the frigid air outside. This simple principle is the foundation of the igloo's incredible insulating power. But brilliant insulation is only half the story. The architectural design is where the real genius shines through. A traditional igloo has a very specific structure. The entrance tunnel is built to be lower than the main living floor. This isn't just for crawling in and out. It's a cold sink or cold trap. Since cold air is denser and heavier than warm air, it naturally sinks and gets trapped in this lower entrance area, preventing it from flooding the main chamber. Inside, the sleeping and living platforms are raised. As we all know, hot air rises. By sleeping on an elevated platform, you're positioning yourself in the warmest part of the igloo, where all the heat congregates. It's a simple, yet incredibly effective way to harness the natural behavior of air. Now, where does all this heat come from in the first place? The primary heat source is you. The average person radiates a significant amount of body heat, roughly the same as a 100-watt light bulb. In a small, well-insulated space, like an igloo, that body heat is trapped and builds up quickly. This alone can raise the internal temperature dramatically. For additional warmth and for cooking, the Inuit use a special stone lamp called a kullik. Fueled by seal oil or blubber, the kullik provides a steady, low-intensity flame. It offers light, melts snow for drinking water, and adds a crucial extra source of radiant heat, making the interior feel even more comfortable. The combination of trapped body heat and the gentle warmth of the lamp can raise the inside temperature to well above freezing, even when it's minus 40 degrees outside. You might think that a lamp burning inside a snow house would cause it to melt, but this is where the final piece of the puzzle fits in. The heat from inside does cause the innermost layer of the snow walls to melt slightly. However, as this moisture seeps into the snow blocks, the intense cold from the outside air immediately refreezes it, turning it into a solid layer of ice. This process, called sintering, happens over and over. With each cycle of melting and refreezing, the snow blocks essentially fuse together, making the entire structure stronger and completely airtight. An older igloo is much stronger than a new one. This icy inner glaze not only reinforces the dome, but also seals any tiny gaps, making it windproof and enhancing its insulating properties even further. So, the igloo isn't just a pile of snow blocks, it's a sophisticated thermal engine. From using trapped air for insulation to a clever design that separates warm and cold air, and a structure that literally becomes stronger and more efficient over time. It's a testament to human ingenuity. It's a perfect harmony of physics, engineering, and a deep understanding of the natural world. A house of snow that keeps you warm. It's not a paradox, it's just brilliant science. Thanks for watching, and if you found this interesting, don't forget to like and subscribe for more deep dives into the amazing world around us. See you next time.